Test-driven development has long been presented as a miracle cure for correct software development. Books have been written about it, talks and conferences have promoted this practice, and developers seem to can't stop talking about it. However, in practice there are very few companies that actually use TDD on a daily basis for most of their projects. The concept itself is not new, and many of the people that have guided the creation and adoption of computer science have written about it, starting with McCracken in 1957, up to Dijkstra in 1972 when it reached a similar form to the one presented in the year 2000 by Kent Beck, summarized as test first. The basic idea is that proof of correctness should be made prior to the code, or at least should be interlaced with development. Sounds simple enough, yet many companies and developers have problems in adopting this practice. Before anybody gets fired up on this topic, please note that this is not a critique to the practice of test-driven development, but rather an observation-based discussion on the difficulties faced when using test-driven development. The main problem with test-driven development is that unit testing is not a measure of correctness but a measure of predictable behavior. Unit tests guarantee that our code behaves as we expect it to, but the expected behavior might be incorrect, incomplete, or functional only on happy flows. So, using TDD does not guarantee correctness, it safeguards our expectations of the code. The immense value of unit tests is not disputed, but the idea of correctness through TDD is not based on facts, but on expectations. Those who have worked with TDD and have tried to teach others how to do it have met several situations where TDD hindered the development process and had a negative impact on the delivery of the product. In terms of system design, greater focus on smaller pieces of code leads to micro-designing systems, which might negatively influence the design of the overall system. As suggested by the idiom, one might not see the forest because of the trees. This means that developers, focused on small pieces of code, might do a great job on each piece of code individually but in the end, reach a bad system design when the pieces are put together. Both good development and good unit testing require a certain degree of seniority, a good understanding of requirements and good knowledge of the used programming languages in order for development to be done correctly and efficiently. It seems unrealistic to have expectations from people with low seniority to correctly apply TDD in the context in which they have difficulties in writing correct and functional code. Because juniors greatly outnumber seniors in almost any company, TDD is rarely the practice of choice for development. Some implementations are made by trial and error. If you do not know how something should work, the problems you might face, the restrictions added by the used technologies and so on, it is very difficult to test first. The effort of writing and rewriting your tests with every new step you take is frustrating and impractical, especially if you know you are doing several rounds of productive failure to understand what you have to implement and deliver. Unit testing as proof of correctness and as documentation implies that unit tests not only are correct, according to specifications and according to unit testing guidelines, but that they also cover all relevant data flows and specific test cases such as validation, branching, internal dependencies, external dependencies, exception management and so on. Achieving this requires longer development time and more development effort. This might not necessarily be an issue, but the lack of completeness in unit testing, especially if not all requirements, data flows and test cases have been included in unit tests, makes correctness and documentation impossible or worse, misleading. Not all code requires unit testing, for example using JPA, stubs, mocks, DTOs and many other third-party libraries and frameworks. Alternating between TDD and other types of tests, relevant to the aforementioned cases, for example integration tests, is tiresome and easily breaks focus. In other cases, like the user interface, unit testing rarely covers more than basic scenarios, while the actual value of the product and its correctness in terms of UI comes from complex data flows, input validation and user experience, which cannot be covered in any way by unit testing. In order to facilitate unit testing, developers might be tempted to add specific behaviors or structures in their code. If the reason these elements are added to the code is to simplify unit testing, then they become system design issues and break most of the development principles. As you can see, it's not the concept of TDD that is problematic but the time, resources and knowledge required to do proper TDD. Keep in mind that extra effort means extra cost for the client or the company, and in some cases, paying more for test-driven development is actually paying more for less value. This becomes more relevant the bigger the project and higher the number of developers involved. For small-scale projects and savvy teams, TDD might actually work as intended, but forcing it on projects where there is constant change and low seniority seems like a waste of money and time. Thank you for watching this video. Please like and subscribe to the Learn Stuff Academy YouTube channel for more educational videos.